All right, welcome again, everybody. In this video, we are going to go through how to translate something from a symbolic form into a verbal form, numeric form, visual form, and then talk domain and range again. So very similar to the last one. We're just kind of wanting to start in a symbolic place rather than a verbal place, and then see how we can go the other directions. So we're going to start by taking this function. Suppose the function f has outputs which can be computed. Let me start over. All right, so the example that we're going to look at in this video is suppose the function f has outputs which can be computed via the expression f of t equals 3/2 times t minus 4. So we're going to start by re-expressing this function with words, which I've said it out loud, so we're really just writing it. We're going to say the function f takes the input, and the variable we're using here is t, multiplies it by 3/2 first, right? The order of operations is important, and this verbal part really helps us connect that. We take the input t, we multiply it by 3/2, and then subtracts 4 from that value. And that is to obtain the output of f for that input. Okay, so each input has its own output. All right, so let's get a numeric description here. We're going to make a table. We've got t values as inputs and f of t values as outputs. Keep in mind, this verbal description is really important as we are writing this in words and saying it out loud and saying in our heads at the very least. We're building additional connections in our brain. The whole goal of this, we're training our brains. We are getting our neurons to connect in a way that strengthens the neural connections and allows us to see this more clearly and more fluidly and more fluently, so that we can build up our understanding of this as a language and a way that we can think and talk and really deduce things. And I like to say that the beauty of mathematics is that it's a tool for predicting the future. All right, I could wax on about that for a while, but let's jump back to this example. So we want to give a numeric description of this function f. Let's pick out some t values. I'm going to actually think about this before I just choose random t values. I'm going to note in the function's symbolic description that we have a slope of 3/2, that the t values are going to get multiplied by 3/2 before anything else happens. So I feel like it's just going to be wise to choose t values that are multiples of 2. Not because I have to, but simply because then I know that they're going to reduce nicely with the 3/2. Let's see, let's put a 0 in here. It's always nice. Plug in like -2, -4, -6. Let's do 2 and 4, and then let's do something not even just to see what else happens, and maybe something really weird, like maybe not super weird, but 1/2. That's not that weird of a number. 1/2, we can plug that in to see what happens if we start with a fraction, because we can really plug any number that we want to in this. All right, if we take -6, I'm saying f of -6 equals 3/2 times -6 minus 4. We can reduce here. Really practice this. As you do this more and more, these will go faster. You can start doing some of these steps in your head. We get 3 times negative 3 is negative 9, minus 4, this would be negative 13. And we'll try f of negative 4. That's going to be 3 halves times negative 4 minus 4. So the 2 and the 4 reduce to a 1 and it's a negative 2, so we get negative 6 minus 4 equals negative 10. Plug that in. I do f of negative 2. You really don't need to do this many numbers like in practice all the time, but it's nice to get some extra practice in here as we are learning this. F of negative 2 equals 3 halves times negative 2 minus 4. Here the 2's can cancel pretty straight away. And we get 3 times negative 1 is negative 3. Don't let that minus disappear on you. And then minus 3 minus 4 is negative 7. So we plug in negative 2, we get out negative 7. Let's see if we can, let's plug in 0 real quick, and now we're going to try and get a pattern figured out. So f of 0 is 3 halves times 0 minus 4. So this is going to be 0 minus 4 is negative 4. That's our y-intercept. Kind of nice to note. Okay, let's look at these outputs. We have negative 13, negative 10, negative 7, negative 4. So these are all going up by 3 every time that we moved right 2. All right, and then it just keeps going up by 3 here every time x goes right by 2. So if we keep going right by 2, because this is a straight line, I expect this keeps going up by 3. So negative 4 to negative 1, and then up 3 again will get us to a positive 2. 5 is breaking the pattern in how we're going up here. So let's just plug that in. F of 5 equals 3 halves times 5 minus 4. Here this is going to be that 5 is over a 1. 3 times 5 is 15 over 2, and then minus. Here I want to get, well, I'll write this as 4 over 1 and realize I need to get a common denominator. So this is 15 over 2 minus 8 over 2. And 15 minus 8, take a second. That's 7 over 2. 7 over 2 is 3.5. And let's plug in that last one. Let's see if we can have room here. F of 1/2. This is 3 halves times 1/2 minus 4. This is going to be 3/4 minus, if I get a common denominator, I'm going to need 16 over 4. So the 4 equals 16 over 4. If it's a 4 over 1, I multiply top and bottom by 4 to get 16 over 4 so that I can add these fractions together. 3 minus 16 is negative 13 over 4. I probably won't plot that point, but that is a point on our graph that we're going to do next. All right, so here's a numeric description. In practice, again, you don't need to have that many points. Get like 5-ish points on your table. Go with at least 5. Make that a minimum for you. And now we want a visual description. We've got our vertical axis is f of t. Our input axis is a t variable in this one, not an x variable. Remember, the letter doesn't matter that we use, just as long as we're consistent with it. All right, so we have a y-intercept of 0, negative 4. Let's get a scale. Negative 4 down here, 4. This doesn't seem like too crazy of numbers, so I think just going by 1s in all of our directions is going to be just fine. 1, 2, 3, 4, too much. There's negative 8. Okay, cool. So let's plot the 0, negative 4 point. And then we're going to go up 3 over 2, up 3 over 2, up 3 over 2, up 3 over 2, etc. And down 3, left 2. Do it one more time, down 3, left 2. And then I want to draw a line through. That's not a good line. That's better. All right, let's label some of these points. This is the point 8, 8. This is the point 6, 5. We get down into the points that we actually have on our table. 4, 2. We've got 2, -1, 0, -4. This is -2, -7, right? It's also on the table, and then this point here is -4, -10. Cool. So we're not seeing all of the points that we had on the table. The point 5 and 3/2 is right here. So 5, 3 1/2 to say that a little bit better. And this is y equals f of t. Let's see, that 1/2 -13/4. That seems, you know what it is. Oops. My line isn't perfectly straight, so it's hard to tell. That's a little bit off of that line there. Here is that point 1/2, negative. Well, 4 goes into 13 3 times, and it's got 1 left over. It's -3 1/4. So it's just underneath that -3 value there as an output. All right. Let's wrap this up. Let's state our domain. The domain, well, that's all real numbers again, -∞ to infinity, and the range is also -∞ to infinity. Because this line keeps on going left and right for forever, it keeps on going up and down for forever. All right, I believe that is everything for this video. Thank you so much for watching, everyone, and go ahead and do the Now You Try problems shown in Mindomo, and watch the next video, which goes over the solution to that problem. Thank you. See you in the next one.